G'day and welcome to another one of my videos. Today we're going to have a look at sketching another quadratic function y equals x squared plus some number. We're going to have a look at what happens when that number changes that we add or subtract on the end. Again, it is going to form a parabola because it's a quadratic function. So let's get started. So let's have a look at the most basic of quadratic functions, that y equals x squared. And again, we could use a table of values and so on. And, I'm not going to go through too much. I did in my last video of when we complete our table of values, substituting -3, square it, get +9. So be careful with those negative numbers. -2 squared is 4, -1 squared is 1, and so on. And we've plotted those points and on our Cartesian plane or a number plane. And what we're going to do is try and make it a little bit more accurate and plot in some points that are in between, and then join all of those up, and what we get is a parabola that looks like that. So that's something that we've done before. So let's now have a look at what that +c does. So we're going to add some number onto the end of all of those answers that were in that table. So let's have a look at what happens by using an example. So we're going to look at y equals x squared plus 2. So we're going to take all those answers of 9, 4, 1, 0, 1, 4, and 9, and we're going to add 2 to those. So if we do that, completing a table of values, then we can substitute our x values in, using a calculator if we want, and we get 11, 6, 3, 2, 3, 6, 11. And when we sketch those on a Cartesian plane, we get our parabola that looks like that. So this lighter one here is our original, y equals x squared, and then we've now got y equals x squared plus 2. And what you'll notice is our vertex here has actually been moved up 2. In fact, all of our points here have been moved up 2. Okay? And as we get up here, alright, it doesn't look so obvious, but you can actually, if you draw a straight line, all of these would actually be going up 2. Okay, so our parabola, the whole parabola, original one, has now been lifted up 2. So what we'll do is we'll just check again. Let's see what happens when we've got y equals x squared plus 5. So again, we can do a table of values, square the number. -3 squared is +9, plus 5 is now 14. -2 squared is 4, plus 5 is 9. So we've done that for all of those values already. So I'm not going to go through all the ins and outs of that now. Should be alright at that by this stage. And we've plotted it and sketched it, and what we've got is this y equals x squared plus 5. So what we've got before that is here is y equals x squared, y equals x squared plus 2, which was shifted up 2, and now we've got y equals x squared plus 5, so everything's been shifted up 5 from our original y equals x squared. Okay, so the whole thing's been moved up 5 units. And our vertex now is at coordinates across nothing up 5. So our vertex is 0, 5, whereas when it was y equals x squared plus 2, our vertex was 0, 2. So that's an important point to know. But what we want to do now is what happens if c is negative. So instead of adding a number onto there, we're subtracting a number. So what happens when c is negative? Well, basically what it is we've got x squared plus -c. There's our -c value. And a positive take away another number is the same as just subtracting. So we just end up with x squared minus c. So when c is a negative number, then we can rewrite it, and most often you'll see it as x squared minus. So we're just going to subtract c from all of those values of y in the table. So the 9, 4, 1. We would just subtract that value from each of those. So we'll look at an example. Y equals x squared take away 3. So just recognizing that c is -3, which means we're going to subtract 3 from all of our y values in the table. So 9 take away 3 gives us our 6. -2 squared is 4. Take away 3 is 1, etc. So there's our completed table. And then we plot those on a Cartesian plane, and we can see our parabola has been shifted down 3 units, okay, because of that -3. So y equals x squared has now been moved down 3 units. And our vertex would be 0, -3. Okay, you notice that y-axis is still an axis of symmetry, because all we're doing is moving our parabola up and down. So, in summary, when c is positive, we have a parabola that's moved up c units. So it looks like that. So that was y equals x squared plus 2. It's been moved up 2 units. And when c is negative, the parabola is actually moved down c units. Okay, so that was x squared take away 3. And so the coordinates of the vertex become 0 and whatever that c value is there. So what we can now do is just have a look using our GeoGebra program. So I've got one here, y equals x squared. There's our basic parabola. And we're just going to have a look at what happens when we change our parabola. So the value that we're adding or subtracting on changes. So as I add on, you can see over here, it's now y equals x squared plus 0.7. And what it's done is it's moved the vertex up to 0.7. So the coordinates of the vertex would now be 0, 0.7 in grouping symbols. And so as c increases, you can see that it moves the parabola up. When c is 0, we just get our basic parabola y equals x squared. And then when c becomes negative, for instance, when it's -1, you can see we've got the equation y equals x squared take away 1. And all it's done is move the parabola down 1 unit. So by just fiddling with this, you can see that all the c on the end does is moves the parabola up or down. Okay? And that just gives you an idea of that part. So what we're going to have a look at now is we're going to combine a few of the things that we've learned so far. So not only this video, but my previous video. So not only are we just going to add or subtract a number on the end, we're also going to change the dilation of the parabola. So we're going to multiply the x squared by some number out in front here. So we know that a affects the dilation of the parabola. And the c value moves it up or down. So we're going to have a look at trying y equals -2x squared plus 1. So when I do these, I like to break it up into different parts. I first of all look at the x squared, and I know that I have a parabola that looks something like this, a concave up parabola. Then I look at what the coefficient of the x squared, the number multiplying the x squared is, and I notice that that is a -2. So that negative means that it's going to be a concave down parabola. So, concave down, that's just y equals -x squared, and then I'm going to multiply it by a -2, and that's going to change the dilation. And so we get y equals -2x squared looking thinner, okay, or steeper, because the dilation has changed, it's doubled, okay, each of the y values, which means that they're going down quicker. And then what we're going to do is this c value just takes what we've got so far and moves the parabola up 1 because of the +1. So we move the parabola up 1. So the lighter one is the y equals -2x squared, and now -2x squared plus 1 looks like that. You'll notice that it is still symmetrical about the y-axis, and the coordinates of the vertex are the point 0, 1. Okay, So 0, 1 gives us those coordinates of the vertex. And it's pretty much as simple as that. So what you now need to do is to practice and practice some more and practice again. And as I said, break it up into looking at the x squared first, then looking at whether it's concave up or concave down, and then whatever's added or subtracted on the end. So I hope you found this useful and that it makes sketching parabolas of this form so much easier. So thanks for watching.